All right, let's go ahead and do a quick look at the Granta Edupack 2020 while we load up here. All right, so first thing we're going to do is again select our database. I want to look at the advanced utility in plotting equations, and in particular we're going to be looking at this second CES assignment where we want to plot a bar chart. So let me go ahead and select the elements for this one. I'm going to try and fit our CES in here. All right, so we're going to go ahead and we select the elements. We're going to go ahead and select chart like we've done before, and we're going to select here from the elements, so that's all that we want. We're going to go ahead and do the chart index again, and this is the same thing you would do even if it wasn't the elements, if it was like a level 1 or something like that. But in your particular homework problem, you're going to be needing to use the elements database. So the next thing you want to do for a bar chart is to define the y-axis only. That's referred to as a bar chart in the Edupack software, and the x-axis will just be something like element type. It'll handle that by itself. If you were to plot the define the x-axis and the y-axis in terms of properties, you end up with what's called a bubble chart, and that's what you've done before. So let's go ahead and do the bar chart. Now if we're going to do an equation rather than just selecting one property, then we need to go into the advanced. Okay. And here we can write an equation. So I'm not going to do the one that you have for homework, but let's say that we wanted to take a look at let's go ahead and look at mechanical properties. So let's say that we wanted to look at something like 1 minus, so I'm just typing that in, okay? But when I get to a property, I have to put it in through an insert command. So I need to go to Poisson's ratio, for example, if I wanted that, and I have to say insert, okay? Then I can go ahead and type and close my parentheses. I can't type these in. I need to use the insert command to get them right. So far I've got 1 minus Poisson's ratio, and then maybe I want to divide that by something like the bulk modulus. So again, I'll do bulk modulus, and then I'll say insert. Okay. If for some reason, I'm going to go back here to the beginning, I wanted to multiply the whole thing or the top here by something like pi, then what I would do is go to my constants, okay, and then I would find pi, and I would insert it, okay, and again I'm going to need the multiply sign. So I've got pi times 1 minus the Poisson's ratio divided by the bulk modulus. Okay, this doesn't really make any sense, but that's just what we're going to plot here just for fun. If you're doing something like an exponential, then you would go ahead and use this base of natural logarithm. You'd insert that, and then you can use the caret here for the power, okay, just like you do in Excel. If you need the gas constant, then you can see the gas constant here in joules per mole. It says degrees C, joules per mole Kelvin. This is the same as per Kelvin. The difference in degrees C and difference in Kelvin are the same. So that would be our gas constant, or we could do the Boltzmann's constant, just depending on our units of our problem. But that's where you find all this stuff, is in your constants and parameters. All right, so let's just go ahead and see what we get. We'll go ahead and say insert. I should say just offhand, unlike Excel, there's no equal sign out front. Okay, we're just writing the equation in. All right, so go ahead and say insert. Whoops, I didn't want to insert, sorry. I wanted to say okay. Put that back, so again, pi times 1 minus Poisson. So now I just say okay, and it titles my axis according to the equation I just said, and then I'll just go ahead and say okay again. If I want to change the axes, I could certainly do linear versus logarithmic or set min max. But I'll say OK. And it gives me a bar chart. So the reason you can see it's called a bar is because it will give these little bars for every element. Okay, and it's not labeling the elements on this axis, but this would be your element axis. Each one of these corresponds to an element. But since there's some standard deviation in the properties, like a modulus and the Poisson ratio, that results in a little standard deviation in the value here that we calculate, and that's why there's a bar. It represents the range of values for that particular element. And then again, you can come over here and you could click on one of these or just hover, and you could see what elements are what. Okay, and you can always click on one if you wanted to do something like that and label it. So there's aluminum. The other thing you can do if you were looking for something specific is you might not want to have to hover over every one of these to try and find it. So let's say we wanted to do iron. Iron, here we go. What I can do is right click on iron, and then I can say highlight, or I could do label. So let me just do highlight first. So you can see here the highlight, it blinks, kind of lets me know that there it is. And in this case, it also labeled it. Okay, so if I want to do lead, again, I could just say label, and that would do the same thing. Puts a label on it, I can see where lead is. All right, so that's how we could do that. All right, I guess that's it for now.